Now, you should have just finished up your standard 15 video notes, and the thing that you're probably thinking is, how on earth am I supposed to remember all those formulas I was just introduced to? And I am going to expect you to know these for the test. I'm not going to give any of them to you, so that might be a little alarming, okay? But what I want to show you in this short video is how you can reproduce any of those formulas by just memorizing two of them. Okay, just two of them, that's all you need. So here are the two that you need to memorize. All right, I'll put those in red up at the top. So we'll say memorize these. But the nice thing about these two that I want you to memorize is they have a nice little rhyme that help you to remember them. So the two I want you to memorize are the addition formulas for sine and cosine. And the little rhyme for sine is you say sine, cosine, cosine, sine. Okay, and here's what this means. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Sine, cosine, cosine, sine. All right. And then for this one, what you memorize is cosine, cosine, sine, sine. All right. So cosine, cosine, sine, sine. And then you put a minus sign in the middle. So for sine, you see the same symbol here as you do in the argument. For cosine, you do the opposite. So if you can memorize those two, that's actually all you need to memorize. And that might seem rather unbelievable, but let's go ahead and produce all the others. So I think what I'm going to do to kind of hopefully have this kind of stuff stand out is I'm going to have every formula end up in red, and then in black is where I'll do the work that kind of gets us there. So let's say I wanted to know the subtraction formula for sine. The subtraction formula for sine, would you agree, is just saying instead of minus beta, you could say plus negative beta. But then it becomes this formula again. And so then all I have to say to myself is sine, cosine, cosine, sine. Okay. Now the cosine of negative beta is the same as cosine of beta because it's an even function. The sine of negative beta is the opposite of the sine of beta, right? So where am I taking that from? Right, here's cosine. Sorry for the sloppiness, but in other words, if you go on the negative side, but you go equivalent on the positive side, they're the same. So that's why that can just go away. But then the sine of negative beta, okay, so whatever's happening on this side, the opposite's happening on that side. So we pull that negative out. And another way people just, at this point would like to memorize it is, okay, when it's minus, you put a minus in between them. So here's another one. Sine of alpha minus beta is equal to sine, cosine, minus cosine, sine. Now you might say to yourself, well, geez, I'd rather just memorize that that's what it is rather than go through all that. And that's totally fine. I'm just telling you how to reproduce it if you forget it. Okay. And then we can do the same thing with cosine. Cosine of alpha minus beta, cosine of alpha plus negative beta, cosine, cosine, sine, sine. But of course, this time that's still the same as just regular old beta, but then this negative comes out of the sine, so this is going to be plus sine alpha, sine beta. So if I had forgotten it, then that would remind me that cosine of alpha minus beta equals cosine, cosine, sine, sine with a plus in the middle. So at this point, though, you could just memorize that with sines, the exact same symbol is in the middle, and with cosines, the opposite. That's the same thing with these two. All right, now let's suppose that I'm trying to remember let's change colors here. I'm trying to remember the double angle formula for sine. Okay. Well, can we all agree that that's the sine of theta plus itself? And then I can just use that formula. So this is sine, cosine, plus cosine, sine. But these are the same, right? So it's just 2 sine theta, cosine theta, right? So just like that, we've got the double angle formula for sine. Okay. All right, so now how about cosine? So cosine, you'd say, well, what's the cosine of 2 theta? Okay, well, that's the cosine of theta plus theta, which is cosine, cosine, minus sine, sine. But of course, that's cosine squared theta minus sine squared theta. But there's your double angle formula for cosine. Okay, but then you might remember that there are also other forms of the double angle formula for cosine. But remember, that's just going to come from saying this. 1 minus the sine squared of theta minus the sine squared theta. So I've changed cosine squared into 1 minus sine squared, which is 1 minus 2 sine squared theta. And so that gives me version number 2 of cosine 2 theta. Okay. And then, of course, version number 3, cosine 2 theta, comes from me replacing sine squared with 1 minus cosine squared. So cos squared theta minus 1 minus cosine squared theta, which is cos squared theta minus 1 plus cosine squared theta. So then that leads me to version 3 of the cosine of 2 theta. All right. So with all that, we memorized these two, and we were able to come up with these other formulas, all just based on our knowledge of that and I guess the Pythagorean identity. Okay, but we're not quite done yet. there's a couple others, right? There's the power lowering formula. So the power lowering formula, what it does is it allows us to rewrite, and actually let me start with red here. I'm going to give myself a little bit of space. The cosine squared of theta, it allows me to write the cosine squared of theta and the sine squared of theta without any powers in it. All right, so where does that come from? Well, they both come from the double angle formula for cosine. So this one is coming from this double angle formula for cosine that we had on the previous page. So I add 1 to both sides. So this is going to be 1 plus cosine 2 theta equals 2 cosine squared theta, and then divide by 2. So that gives me my power lowering formula, 1 plus cosine of 2 theta all over 2. And then the sine squared also comes from my double angle formula for cosine, but the one that involves just sine. So I can subtract 1 here, so I have cosine 2 theta minus 1, negative 2 over sine squared theta, but then I'm going to divide by negative 2, and then the only adjustment I'm going to make as I write it down here is I'm going to let the negative be with cosine 2 theta and the plus be with 1 when I divide by negative 2, so this will be 1 minus cosine 2 theta over positive 2, right? So just switch the signs on everything there. So there's our power lowering formulas. And then I almost don't even like writing these out because to me it seems redundant. But there's also the half angle formulas, but just understand the half angle formula just means that since you're chopping the angle here in half, you also need to chop the angle here in half. So you see it's really not a different formula at all. And then if you want to know what the cosine of theta over 2 is, then you're just gonna look at what quadrant theta ends in to, or theta over 2 ends in, determine whether the cosine of theta over 2 should be positive or negative, because you'd take the square root and it'd be plus or minus, and then you make that decision based on that. So there's all your formulas. Now, was that easy? No, I know that wasn't easy. I know that's you're not going to want to go through all of that on a test, but I want you to understand we never used anything except these first two. None of the rest of this was memorization, okay? So is it good to try to make sure you memorize your double angle formula for sine and cosine? Yeah, I'm not telling you not to memorize it. But what I'm saying is in a pinch, you're not sunk, okay? Write out these two and then find your way there, okay, to whichever one you need.